Chapter 17, Markov Decision Processes, its application in healthcare. This is a summary of the 17th chapter from the Handbook of Healthcare Delivery Systems. The initial chapter was written by Jonathan Patrick from the University of Ottawa and Meheb Beyan from the University of Western Ontario. The takeaway message is that a Markov decision process may be the right tool to use when there is a question which involves uncertainty and sequential decision making. Much of the math has been left out of this chapter summary, and the big takeaway point is that there are times when you have sequential decision problems, SDPs, and these are multi-step scenarios where each step becomes contingent upon the decision made in the prior step. And a Markov decision process can apply a mathematical model to analyzing these sequential decision problems. The text outlines 5 components of a Markov decision process. First, there's a decision maker, and they will make decisions at particular intervals. It'll either be fixed intervals or variable intervals. The second component is there's a concept of a state, and that is the decision to be tracked, and the state space is all potential states or decisions which can occur at a particular place. This can then lead to potential actions, and the actions are the effects which can happen at each state. And then there's also the fourth, which is a transition, which is a probability and the estimate that a particular state will be visited based on a prior decision. Ultimately, this leads to number 5, which is a reward or cost, in that a particular new state may be either good or bad, and this reward or cost can be calculated. So again, there's a decision maker, which changes the patient's state, and then that state can ultimately lead to different actions, and there's a probability which leads from one action to another, and when you do get to the next step, there's a reward or cost to be calculated. Some examples given in the text include use of this Markov decision process to hospital admission scheduling, a lot of booking problem examples. For instance, you have to judge both the patient's current acuity, meaning that you can't book all low priority patients today, or there won't be room today for high priority patients. And so looking at how to do this to book OR scheduling for elective and emergent surgeries, MRI booking, CT scan machine booking. Similarly, the Markov decision process has been used to answer questions like when to start HIV treatment, when to start statin therapy, to assist in patient decision making, and help with live liver transplant schedules.